Okay, folks, welcome to Lecture 9. So, in this lecture, we'll be taking a look at powers or exponents. First of all, though, we're just going to take a look at a few variables because it's I'll be using some of this terminology, so it's good to define what we're talking about first of all. So, a variable is a symbol. So, as soon as letters start appearing, we're okay with numbers. But as soon as letters start appearing, now we're in the world of variables. So often variables could appear as A, B, C, X, Y, Z. X, Y is used very commonly in maths. The main thing is though, guys, is these are still numbers. We just don't necessarily know what they are yet. So any letters that represent a value is called a variable. Any number on its own is called a constant. So we could have, say, 3a plus b plus 7. Now the 7 is the constant number on its own. Any number in front of a variable is a coefficient. So just again, guys, it's just to get familiar with the language. I'm not going to be, it's just so we know what we're talking about. So here we have coefficient, a variable, constants. Our sign is an operator. We know the inverse operator then is plus. And that's just some of the words we'll come across. On the next slide, we'll come across a few more, but first I'll just clear all this. And a variable on its own. So say if we had x minus 3. Any variable on its own automatically has the number 1 in front of it. It's just we usually don't write it. Same way as a variable on its own like that is automatically plus, and it's automatically 1. But usually, guys, it's not necessary to write those, so they're often omitted, but they're implied. There's no other number we could be. If there was minus there, it would still be minus 1. Now, here, guys, we have an expression. An expression is made up of several terms. So each bit in an equation or an expression is a term. Terms are separated by pluses or minuses, equal signs, and often by divides. You could have, say, 3x over 2x plus 1. Now, we've one term on the top, and we've two terms on the bottom. So I'll be talking about the terms a good bit in this lecture. So an expression is a collection of terms. So here we have an expression. And then a member of the family of expressions is an equation. So if you've got an equal signs in there, then we're dealing with an equation. So just something written on its own, say 3x plus 7. That's an expression. There's no equal sign. When we throw in an equal sign, now we have an equation. This equation has 3 terms. It's got 2 constants. It's got 1 variable, and it's got 1 coefficient. So just to be conscious of the language. So now we're going to kind of move away. That was just I kind of wanted to define that, so I felt this was as good a place as any. Now we're going to actually take a look at the lecture proper and look at powers. So any number multiplied by itself is said to be raised to a power. So 2 by 2 by 2 is 2 to the power 3, or 2 cubed. 4 by 4 by 4 by, or sorry, 3 by 3 by 3 by 3 is 3 to the power 4. X by X by X. Notice we use the dot here. We don't use the X because it gets confusing. So often a dot is used whenever variables are involved, because you could have 3x multiplied by x, and it suddenly starts to look very confusing. So a dot is often used, or brackets. Y to the power of 5. So essentially, guys, the power is the number of times the variable is multiplied by itself, or the value. Often referred to as indices or exponents, they all mean the same thing. So just don't be put off if you see the word index, indices, or exponents. It's all the same thing. The rules are the same regardless of what you call it. And in the following lectures, I try and kind of switch between the three so that you get used to all three meaning pretty much the same thing. So we're going to just define things now. Here, guys, we have 10 to the power of 6. Now that's really 10 that's what that means. 10 multiplied by itself 6 times. The bottom is called the base. The top then, the power, the index, or the exponent. That's the number of times 10 is multiplied by itself. So 6 to the power of 10 is obviously something completely different. That's 6 multiplied by itself 10 times. So just be careful, guys, because as we move along, first things, all the rules we're going to take a look at in the following slides, they must have the same base. So we'll take a look. So the first rules of powers, these are essential. We have to kind of define these before we move any further. If we're multiplying two values, first of all, they're both power terms. They must have the same base. So that's the first condition. And if they do have the same base, guys, when we multiply them, we add the powers. So we look at an example. 10 to the power of 4, well, that's looks like this, multiplied by 10 to the power of 1. So now we can see we've got 10 to the power of 5. How we get there is we simply add the two powers. Now we'll be doing lots of examples of these on Moodle, guys, so I'm not going to kind of labor the point. We'll just move on. The second rule is if you're dividing two powers. First, once they have the same base, then we subtract the powers. So here, guys, we have 10 to the power of 4 divided by 10 to the power of 1. How that would look like this. And now we know by cancelling, 10 will go into the top and the top bottom. So we've got 10 to the power of 3 left. But we don't have to do that, guys. First of all, on the bottom here, even though it's not written, there's a 1 implied. So I kind of left that out deliberately to emphasize that point. So anytime there's no power written, guys, you can always just write it in as a 1, and then you just do the maths as normal. So now subtract the lower power from the upper power. It's crucial to do that, guys. Don't just say the biggest number minus the small number. It's always top power minus the bottom power. And take particular care if there's minuses already involved in the powers. So there's the second rule then. Once they have the same base, we subtract the powers. If we're dividing two values, we subtract the powers. Third rule is just simply anything to the power of 0. So 10 to the power of 0 is 1, minus 10 to the power of 0 is 1, 3x to the power of 0 is 1, 3x over 90 all to the power of 0. It doesn't matter if it's to the power of 0, it's equal to 1. If we stick a minus sign in front of it, it's still equal to 1. So anything to the power of 0 is equal to 1. Where it really comes from, guys, is the only way you could end up with, say, if we were doing a to the power of 5 by a to the power of 5. The only way we'll ever get a to the power of 0 here is if we're dividing the same value by the same value, and that's why it always has to be 1. And even if both of these were negative, we would still end up with a plus 1. So that's where it comes from. I don't want to labor it too much, but just anytime you see power to the 0, that's equal to just the number 1. All of these guys are gone over in more detail as well in the videos and in the notes as well. I'm aware I'm kind of moving through them fairly quickly, but I just want to kind of get them laid out. I always think this is the most important rule for scientists, is any value that's below the line, any power value that's below the line, bring it up and change the sign. So that's what's gone on. I've brought the whole power term up, but I've simply changed the sign on the power. So 1 over 10 to the power of 4 is written as 10 to the power of minus 4. This is not a negative number, guys. It's a very small number. That's what it looks like, but it's still positive. So any value, guys, between 0 and 1 will always have a negative power. And then any value greater than 1 will always have a positive power. We'll take a wee look though. So another example, guys, where this becomes really important is, say if we were talking about acceleration or speed first, meters per second. That's really meters over seconds. Very often, guys, meters per second is written like that. So you'll often see units with negative powers, and that just means that unit is living below the line. It's a divisor. Similarly, units of acceleration, meters per second squared. The second, as soon as you see the word per, that means the next bit lives below the line, and very commonly written like that. So as a scientist, guys, you've got to recognize these negative powers on units and what they mean. Now we'll be doing a lot more work with it. I'm really just introducing the concept at the moment. The last 2 rules, don't worry, we're nearly there. Here, guys, the kind of example here, we say if we had 5 squared and this was to be cubed. Really what that is 5 squared. Well, that's 5 by 5. And then it's multiplied by itself 3 times. So this will give us 5 to the power of 6. Now how you get there is you multiply those 2 values. So this is different than rule 1. Remember rule 1, we added the powers when they were being multiplied. So don't confuse them. Here we're now multiplying the powers. So 10 squared to the power of 4, rather than writing it out like I just did, would now be 10 to the power of 8. Last rule then, guys, comes up a good bit, is if you ever come across the surd, it's a weird word, but a surd, guys, is this symbol or any of those symbols. A surd is kind of a language in maths in itself, writing in surds and stuff. You probably did a little bit of it in the junior cert and leaving cert. I don't really deal with it at all, but we've got to be able to switch from surds into the language of powers. And this is where it comes about. Now in the video, guys, I explain where it comes about. I'm not going to spend ages kind of talking about it too much. But really, it's just because if we have the square root of something by the square root of something, that will generally give me the value a. if I convert these into powers, I'll just do it real quick. I don't know what the square root is, so I'm just writing it in as a question mark. Now, because of rule 1, I'm multiplying these values. So now it will be a to the power of 2 question marks is equal to a to the power of 1. And because the bases are the same, 2 question marks is equal to 1. So the question mark, usually I'd call it x, but I don't really, has to be a half. So say if you were given the square root of 10, you can get rid of the square root symbol and write it as a power of a half. And then all the other rules will apply as well, and you can work your way out. We'll take a look at a few examples with these later on. So just a quick summary. Now, just with the last one as well, guys, if you came across a cube root, that's, say, the cube root of 8, what number multiplied by itself 3 times gives me 8? Well, that's 2. 2 by 2 by 2 is 8. There's also, guys, a fourth root. We won't come across it anywhere in this module, but mathematically. So you could go on and write fifth roots. It's fairly logical, the pattern that's followed. We'll come across this rarely, guys, on either this module or the next one, but we'll come across this fairly commonly. So we look at a couple of examples. So here, guys, reduce this to a single power term. So it's going to have to be a base of 10 and then a power of something. That's what I mean by a power term. So how you do these? First of all, we'll just check. Well, I'm going to write a 1 in there at the top, just in case you didn't see that, guys. Just here, the 10 with no power, we just write in a 1, because now everything has a power. So the top line, guys, I'm going to work that out first. They're all been multiplied. Using rule 1, I'm going to add the 3 powers. 1 plus 4 plus 2 is 7. On the bottom, guys, I have 10 to the power of 3 raised to the power of 2. So that's rule 5. I multiply the powers. And now, guys, I have 2 values, both with the same base. They're being divided, 2 power values. So using rule 2, I subtract. Be very careful, guys, the upper power minus the lower power. It's always good practice, guys, to write that out properly. Because once there's minuses in here, then you need to be very careful. So our answer then, reduced to a single power term, is 10 to the power of 1. Another one. Now we have the square root, so I can actually just convert the square root, guys. That's my first job, is just convert that into a power. Now on top I have 10 to the power of 6 divided by 10 to the power of 2. I just prefer to write them as fractions, guys. You don't have to. And now, guys, on the top of this line, I have 10 to the power of 6 divided by 10 to the power of 2 using rule 2. I'm going to subtract the powers, and that will be 10 to the power of 4. Now my 10 to the power of a half, my square root is still waiting. Below the line now, guys, I have 10 to the power of 5 divided by 10 to the power of 3. Again, I subtract the lower power from the upper power, 5 minus 3. Again, now inside the brackets, remember BODMAS. 10 to the power of 4, that becomes upper power minus the lower power. So that will give me 10 to the power of 2. This is still waiting outside. And then because of rule 5 up here, 1 power raised to the other gives me 10 to the power of 1. 2 multiplied by a half gives me 10 to the power of 1. And again, that's my answer there. It's just a coincidence it's the same answer. The answer to all of these is not 10 to the power of 1. So now guys, first bit of work for you guys to do. Oh, the square root is in there as well. Sorry, that was that's just that rule appearing. So now you know the crack. Pause the video, have a go at these ones. Take your time guys, work out the top line. Really in here you want to work this into a single power term and then bring the square root into play. Same here, work on the top, work on the bottom until you get a single power term. And same here guys, work on the top, work on the bottom. You won't encounter anything like this in science, similar enough, but not exactly in this format. In science, guys, we don't tend to use these bases at all. We used to use a base of 10 or a base of E, which we'll come across shortly. So have a wee go at them. Now these guys are just fairly similar, but we're now using variables instead of constant terms. But the rules are the exact same. Remember, a variable is simply a number. So first of all, I'm going to write my write my square root as a power and a half. You can do this later if you want. I just like to convert everything into powers at the start. Working on the top line, guys, they've been multiplied, so I add the powers. That's an A there. I'll just make that look a little bit less like a 9. On the bottom, guys, again, they've been multiplied, so we add the powers. Minus 5 plus 2 gives me A to the minus 3. Now, this, guys, is where we have to be very careful. Keeping our square root. I'm now using rule 2. I'm subtracting the top power minus the bottom power. It's very important that we get this right. So we've already done examples like this, guys, at the very start of the module. So try and remember the rules. This is double negative, so this will become a plus. So we'll have 9 plus 3. We have A to the power of 12, all to the power of a half. Using rule 5, we multiply, and we get A to the power of 6. So that's the first one done. On Moodle, guys, I think it'll usually just ask you to enter the power on A, so in that case you would just enter in 6. We'll take a look at another one. A little bit more complicated. I just tried to make it tricky for the example so you'd see, even though it looks tough, it's just breaking it down into sections. So top line, bottom line, work on those. Again, I'm going to write the square root outside as a power. That's rule 6. If this doesn't come in though, guys, this half is waiting until the very end. So he's the very last step to be taken. Because of BODMAS, we have to work anything inside the brackets first. So now, guys, on the top line, again, using rule 1, I'll add my powers. 5 plus 3 minus 4. And that'll give me 8 minus 4, 8 to the power of 4. On the bottom, guys, again with BODMAS, I have multiplication, but I have this cubed first. Now, cubed, guys, is really 1 over a squared by 1 over a squared by 1 over a squared. So top by top by top is 1. Bottom by bottom by bottom, I add the powers, is a to the power of 6. So on the bottom, I'll have a to the power of 6. And then, guys, when I multiply this by a to the power of 4, that'll give me a to the power of 4 there. I hope that makes sense. So that's the first bit, and then I multiply it by this bit. Just tidy this up a little bit. And now, again, I'll keep my half. On the top, I have a to the power of 4. Always just take it step by step. And on the bottom, guys, I have a, remember, top power minus the lower power. So that will give me minus 2. Now, again, it's the same rule. So that was to get me that bit. That's the minus 2. That's where that's coming from. And now, guys, again, it's top power minus the lower power. So this, guys, is where the mistakes are made. Just people not paying attention. This will become a plus. Sorry, the half is still waiting. A to the power of 6, all to the power of a half. We multiply the 6 by the half, and my final answer is a to the power of 3. So again, guys, these are just exercises just to get you practicing the skills. Like I said, you'd be very rare you'd encounter these in the field, so to speak. So you know the drill, guys. At this stage, pause the video, have a wee go at these ones. Oh, sorry. And now, guys, so that's the kind of rules, that's how the rules are applied. Now what we're going to do is just take a look at a few other things, kind of more of a bit of housekeeping to do with powers, like we had to do with fractions as well. So we'll just take a look at a few of those now. If there's any numbers, constants, and our powers, any coefficients, constants, they behave as normal. So numbers follow numbers rules, powers follow power rules. Numbers do what numbers do, powers do what powers do. That's what I'm trying to say there. So say if we have these two power terms been multiplied, what this thing at the bottom is saying is, well, numbers do what numbers do. We have 5 by 2. But first of all, guys, even before we do that, we check the sign. This one is positive and this one is positive. So whatever else, my answer is going to be positive. Now we look at the numbers. 5 by 2, that gives me 10. And then, guys, powers do what powers do. We have x to the power of 2 multiplied by x to the power of 3. So we're going to add the powers. And there's our answer. Similarly, quickly run through that in your head again. What's the sign going to be? The sign is going to be negative. What's the number going to be? Minus 10. And what's the powers going to be? We add the powers, y to the power of 2. So that, guys, any of these, that's how you do it. Sort the sign, sort the number, sort the powers. 3 separate steps involved in each solution. And if you follow that kind of pattern, guys, you'll kind of stay quite safe as you work your way through what look like very tricky problems. So that's that slide. Numbers do what numbers do. Powers do what powers do. If there's different bases, guys, so say if the bases aren't the same, then none of the rules we just looked at apply. Those rules only apply when the bases are the same. If the bases are different, guys, the powers just stay with their own bases. The powers cannot be added or subtracted or anything like that. They just stay with their own base. I'll show you. So here, guys, now again, numbers still do what numbers do. So we're still going to have 10, but now the x squared and the y to the power of 4, the bases, guys, are different. So we can't add the powers. The bases just stay with their own power. Here again, we have 6. Now again, remember, guys, there's the implied 1 in there, the minus 1. So that's 6 by minus 1. I'm going to have minus 6. And then, guys, I cannot do anything with the powers because the bases are different. So each base keeps its own power. There's no mixing, there's no change on the powers associated with each base. So that's bases. Bases are different. Generally, your life is not so much easy, but it's straightforward. Numbers will still do what numbers do. They're kind of unrestricted by what's happening in the power world. Brackets and powers. So this, guys, is a very important consideration. Is if there's brackets, things are changed considerably. So we could have 2x squared, and then there's 2x to b squared. So these are actually completely different things. So it's very important whether there's brackets there or not. The first one, guys, simply is, as you see it, only the x is squared. In the other one, guys, basically, if there's 2 parts in a term, if it's getting squared, then each part, each element gets squared. So taking this up here, essentially the 2 will get squared and the x will get squared, and the lower one, guys, is 4x squared. So it's very important to be aware of whether there's brackets there or not. So we'll take a look. We have 3x squared. Like I said, both elements get squared. Now be careful, the 3 gets squared. 3 squared is not 6, it's 9. 3 by 3. That would give us 9x squared. This looks a bit trickier, but essentially, guys, each element gets squared by this one here. And now we just apply the rules individually. 3 squared, like we saw, is 9. Here we multiply the powers, that gives us 4, and we get b squared. Notice different bases, so there's no mingling of the powers. A little bit more complicated. First of all, we'll write the square root as a power of a half. And now this half comes in and affects each element independently. And again, now here, 9 to the power of a half, that's really the square root of 9, which is 3. Four by a half is 2. That's what gives me my a to the power of 2. And then 2 by a half gives me b to the power of 1. And there's my answer. So we just take a look now. There's a few examples for you guys to try. So pause the video, have a wee go at these. Remember, just bring the cube, guys, this into each term, each element of the term independently. Similar here, a little bit trickier. And similarly here. So just give them a go. We'll be working on similar ones in tutorials as well, guys, so make sure you kind of come along to them. So we're nearly there, guys. Just one more thing to take a look at. It's just to introduce the idea of the reciprocal. Simple concept, very powerful mathematical tool though. So the reciprocal of a number, say if we have the number 3, the reciprocal is simply 1 over that number. That's the reciprocal. So if n is the number, then its reciprocal is 1 over n. And remember, that could also be written using rule 4 that we just looked at in this lecture as n to the power of minus 1. So if we have the number 7, the reciprocal is 1 over 7. An easy way, what I always like to think of a reciprocal, guys, is just write the number as a fraction and then turn it upside down. We'll see this here if we actually have to get the reciprocal of a fraction. Well, 1 over the fraction is really what the reciprocal is. But remember now, we flip the lower and multiply. And that's what will then give us 3 over 2. So essentially, to get the reciprocal, we just simply write the number as a fraction and flip it. Now the reciprocal, guys, shows up in lots of places. We're going to meet it very shortly in unit conversions. And then later on this semester, we'll be meeting it for the slope of a line, etc. as well. So very important mathematical concept. We will be meeting it again. Okay, guys. Oh, sorry. A couple of questions for you guys. These are very simple. Remember, just write them as a fraction, turn them upside down. It's just have to define it. So the best way to do that is make you do questions. Okay, folks, I'll finish up here. Thank you very much for listening, and we will meet you again for lecture 10.